Hello, everyone, and welcome to the show. I'm Martin Willis, your host, and we have our guest Avi Loeb coming up. He is running a little bit behind. He was in another interview earlier, and I just got a message from him. He's running a little bit behind, so we have a little time to kill here. And I will ask you, people that are listening and watching live in chat, if you want to throw a question my way, maybe we can get a conversation going that way. But again, Avi Loeb, Harvard astrophysicist, is coming up within, I would think, probably within 5 or 10 minutes, he should be joining us. A quick announcement, the holidays are coming up. I got this email from the Ariel Phenomenon, the movie, through Randall Nickerson. I tried to get him just now to see if he was available, but he's not. But the Ariel Phenomenon movie is going to be available on Christmas Day on iTunes, Apple TV, Google Play, YouTube, and Amazon Prime Video in the US and the UK. So also, if you go over to the website, his website, arielphenomenon.com, I believe it is, there's some merch for sale too. T-shirts just in time for Christmas, things like that. And anyway, I really think it's one of the most beautiful films made on this subject, and to me, I consider that the top case as far as being fascinating, in my opinion. And all those school children just seem so credible, and they never really strayed from their stories. I believe whatever happened, whatever it was, did happen to those kids. And Randall Nickerson did such a beautiful job with the film. And I know a lot of people that pay attention to this topic have already watched it. I've watched it a couple of times, maybe 3, I think, at this point. And I really was looking forward to seeing it in the theater when I had ended up having to have surgery and miss that big event when that happened. In I think it was Western Massachusetts. Northampton, Mass is when that, I can't remember when the date was, but I was out of commission. And anyway, our blog this week by Charles Lear is Hayden Hughes and the International UFO Bureau. So let me take a look at chat here, see if there's any questions. Greetings, everyone. And let's see. No questions yet, but if anyone has a question, let's see if anyone put anything here. I see Bobby, Mary Grace. Hi, hello, and all good to have you all in here. Cali Kid. Here's a question. Let's see. So, Martin, how do you feel about the possibility of an ammonia-based creature from the documentary? Oh, you're talking about James Fox documentary. I don't know about that, if that would be a type of building block that would work. I know they speculate that there could be silicon, like a silicon-based, besides carbon-based life. Why that being had such an odor, I don't know what the makeup of that was. And it would be really interesting to know, and to think that there's possibly some information out there in Brazil about when they did the autopsy on whatever, the supposed autopsy. I don't know 100% sure that any of this, can be documented or not. But anyway, it was, to me, I think it was a very good case. And that's called Moment of Contact, James Fox movie. And if you haven't watched that, it's another great one here. Now I just, hi Martin, any thoughts on the nuclear fusion breakthrough announced today? I heard that was announced today, and I'm really, really excited to read about it. I've been traveling all day. As you can see, I'm in a hotel room, and I had that article sent to me, and I can't wait to read that. It's very exciting if it's a breakthrough, because that would certainly solve a lot of problems that we have. And here's another question here. Have you seen David Paulides' new UFO 411 movie? I have not. Now, I met him a few years ago down in Cherry Hill, down in New Jersey. And I know that he used to really be into the UFO topic, but he was steering completely away from it when he was doing those 411 movies and books. I mean, he did that one movie and some books. So I knew that he was into the UFO topic, and I had a private conversation with him and asked what he thought about that aspect of it. So he did not want to be on this show. He wanted to kind of distance himself from the UFO. But it looks like if he has this movie out, then it looks like it's time for me to get in touch with him and see if I can get him on as a guest. I have not seen it, or I didn't even know about it. But thank you for posting that. And thank you, everyone, for posting these questions. You're keeping me going while I'm waiting for Avi Loeb to come on. Here's another one here. Martin, what is your view on the lack of promise UAP report by our government? Lack of promise UAP. I don't know what's going on. I know that right around Halloween time, we were supposed to get another report. I have not really heard much of what is going on with that and information. I would like to know more about. I know that they're supposed to report publicly, so I know I do believe there was something about their thinking, or they're trying to point the finger that these are drones. A lot of these things are drones, but I don't know how far they're going to be able to get with that, with all the other cases. And I think 2023 should be very promising as far as the investigations that's going to go on, because they're going to go all the way back to the 1940s, which is fascinating. There's so many, as anyone that follows this topic knows how much great information there was back in the starting in the 1940s forward. A lot of people will say, well, these could be secret, government programs and all that, but they kind of discount all the fact that these have been seen for, decades and decades, doing all these unusual maneuvers that we can't explain. I did not hear of any increase in sightings, but our guest, Avi Loeb, has shown up. He's here. Avi, welcome.
Thanks for having me. It's a great pleasure to join you.
Yes, I'm so glad you showed up. I was getting a little bit nervous and kind of running out of things to talk about, but everyone was gracious enough to post some nice questions up for me. So welcome back. You're an extremely busy guy, and I am always impressed with well, first of all, I'm always impressed that you answer my email right away. I mean, you must get 1,000 emails a day or something like that.
Yeah, well, today was particularly busy because I was going over the final draft of my new book that is supposed to come out in August 2023, at the end of August, and it's called Interstellar, and it should be interesting. I just finished going over it.
Wow. So with everything you do, you find time to write a book as well.
Well, that's very important. It's sort of like a diary summarizing my thoughts about the past and the future. And it's not so much about me as it is about what I find most important these days, And I reached a point in my life where I care less about my personal fate and what happens to me, and more about what will happen to humanity and what the future may hold, and how can we make the future better than the past. And that's pretty much what my book is about.
Wow. That's really great. I'm going to put up right here, I wanted to put up your articles that you write, because again, here you are writing all of these articles. It's just amazing. And I've skimmed through a couple of them, and just I'm very, very impressed, because you look at these, it's just almost like every day.
Right. And the only reason today's article will be a little delayed, I'll write it after we speak, is because I was engaged with the new book, Interstellar. That's the title, and it's HarperCollins. It's already on the website. Today's news, I had already 2 interviews in the morning about it, is the announcement of ignition at the nuclear ignition facility using lasers to compress a pellet with hydrogen. And they demonstrated fusion is possible in the lab, and they created a small star, a tiny little star for a short period of time. And that's an accomplishment. And it's sort of an imitation of what nature did for many billions of years, which is stars. At the center of a star, you get the nuclear fusion of the same nature. And the only difference is that a star like the sun is held by gravity. And so the nuclear fuel reaches very high temperatures, but doesn't explode, doesn't run away, because gravity binds it. For that, you need a very massive object. In our laboratories, gravity is completely irrelevant. And so we need some other way of confining the hot gas that is, hundreds of millions of degrees that is fusing. And the way they accomplish that is with laser beams. Basically generating X-rays that compress a pellet, and it reached ignition, and that was a major feat of engineering. I mean, it's not new physics, it's just imitating nature, just the way that the Wright brothers were able to imitate birds. Humans saw birds for so many centuries, and about a century ago, in 1905, the Wright brothers demonstrated that humans can do it as well.
So what is this? What do you think this means? Where do you think this can go? I mean, there has been talk about this in cold fusion. That's a whole different thing, isn't it?
Yeah, no, this one is hot fusion.
Yeah.
Cold fusion was not demonstrated to work. And the original experiments were repeated and did not produce results similar to those claimed originally. So we don't know if cold fusion is possible, but hot fusion has been attempted for many decades. And the issue is really how to confine the hot gas at hundreds of millions of degrees. And the one approach that was very popular is using magnetic fields, very strong magnetic fields. And the biggest demonstration of that is the ITER experiment in Europe, but that's a gigantic facility, and we haven't reached the milestone of ignition there. The approach taken at Livermore that was announced today in terms of being successful was to use a lot of laser beams, very powerful laser beams that shine into a cavity inside of which there is a pellet, and the X-rays generated as they interact with the walls, all these laser beams, they compress the pellet to very high temperatures and densities such that it ignites. And the challenge in that method, it's called inertial confinement. The challenge is to get a uniform collapse contraction of this pellet. And it's very easy for it to collapse along one axis, and then it just becomes a pancake and you don't get the high temperatures and densities. So they managed to accomplish that. That's a major achievement. But it's not clear whether it will become practical for two reasons. One, you have to replenish the pellet. So it's a very sort of, it's sort of like an engine that operates on tiny explosions. You can think of it as a tiny nuclear explosion and fusion explosion. So then you need to replace the pellet every so often, and in order to gain enough energy that can power a city. But then in addition, you have to extract the energy from the system, and the energy comes out in very energetic neutrons. And it's not obvious that the engineering of how to extract their energy is so simple. So I'm not much more optimistic that nuclear fusion will become practical. It will take decades. It's just a major feat in terms of humans being able to imitate nature. That's the significance of it.
Yeah, that is. And it would be great, though, if I understand there wouldn't be the hazardous waste like there is with nuclear power if they could figure this out, right?
Right,
Not as
except
much.
it could happen on the walls depending on how you absorb the neutrons. But indeed, the material, the fuel itself is not producing radioactive debris that could cause problems. I should say that fission is known to work, nuclear reactors work, and it could be the best source of clean energy in the future, irrespective of what happens with with fusion if we build the safe reactors, which is a possible way for us to maintain, our long-term energy needs. So I wouldn't say that fusion is a must for our civilization to get its energy in the long-term future. We could get the best source of clean energy out of nuclear reactors that based on fission, and it's just a matter of engineering it so that we prevent any catastrophes.
Right, right. And yeah, we'll see how that goes. Yeah, there's been hope for cold fusion. I know there's a private company in Washington State that thinks that they're going to be able to crack that problem. And I don't know. I mean, they are working on it, and they are well funded, from what I understand. And that would be really something if they could figure that out.
Altogether, any such breakthrough would help perhaps to venture into space, because as of now, all the spacecraft we launched were based on chemical propellants, and
right. Yeah.
They produce much less energy by a factor of almost 1,000,000 per unit mass of fuel. So if we are able to manufacture relatively small either fusion or fission reactors that can be used as engines for spacecraft, that would be amazing. But as of now, the limit of on the terminal speed of all the spacecraft that we launched since Sputnik until New Horizons, all of them reached tens of kilometers per second as the terminal speed, and that's the tyranny of the rocket equation. The problem is they carry their own fuel, and they cannot reach speeds that exceed by more than one order of magnitude or so the exhaust speed of the gases coming out of their exhaust, because they have to carry the fuel. So the rocket equation doesn't allow you to reach very high speeds just because of the exhaust speed of chemical propellants. But with nuclear, you can reach much higher exhaust speeds.
Now, has there been any further advancement on the Starshot that you were involved in?
Right. So that's a completely different approach, where you say, instead of carrying the fuel, the spacecraft is being pushed by some external force. And in this case, it's light, a beam of light. And the idea is to have a lightweight sail, just like the sail of a boat, which is being pushed by reflecting light. And we were thinking about a very powerful laser shining at a sail the size of a person that weighs roughly a gram, very thin, and then pushes it over a few minutes to a fifth of the speed of light. And then you can attach electronics to that sail. That's the Starshot concept, and we're working on various components of this, and we still don't see a showstopper, but it's very challenging. So building the lasers and also making the sail, it's all possible with existing understanding of how these things can be made, but we are not there yet. We are working on it.
Now, there was a Russian gentleman involved in that? Is he still involved in that?
Well, he's not Russian citizen anymore. He is, he's an entrepreneur from Silicon Valley and a physicist. His name is Yuri Milner, and he still funds this as well as other initiatives such as searching for radio signals or other kinds of signals from extraterrestrial civilizations. That's called the Breakthrough Listen. The other initiative is Breakthrough Starshot.
Mm-hmm. Interesting. Now, we're going to talk in a minute about, I would like to talk about this possible, or this excursion, or whatever you would like to call it, right off of the coast of Papua New Guinea. But before that, I guess I'd like to ask you, you have gotten so much publicity out of, talking about Oumuamua and all that over the last few years since you were on this show. And has the feedback still been positive? I know there was a lot of people actually helping fund the Galileo project. How is all that going?
Well, my book came out less than 2 years ago, and I had about 2,000 interviews and appearances and all,
Yeah.
media outlets. And the book was translated to 25 languages. It became a bestseller.
Wow.
Just to give you, it became bestseller in many countries. But just to give you an impression, I was in two public forums last month, and one of them, an Iranian-born entrepreneur came to me and said, "Can I have a selfie with you?" And I said, "Of course." And then the following morning, she saw me and said, "Did you know that you have hundreds of women scientists in Iran that are following your work?" And I said, I never knew about it, because she posted it in Instagram and she got immediately messages about it.
Huh.
So it looks like all over the world. I mean, that what that shows is that this subject of the search for extraterrestrial intelligence unifies everyone, irrespective of national borders. I was born in Israel. These are women from Iran.
Yeah.
There is nothing. I mean, it brings people together, and I think the more we research the subject, the more we would find there is some low-hanging fruit, because this path that we are taking was not taken. The reason it's very different from the search for intelligence in the past is that we were looking for radio signals or laser signals, and
Yeah.
this is just like waiting for a phone call at home. For that, you need whoever calls you to be active at the time that you are waiting. But there is a completely different approach, which is to just check your mailbox if there are any packages that accumulated over time. The sender may be dead by now, but the packages keep accumulating in your mailbox over the years. And that we have never done. Only over the past decade, we had the instruments that allow us to detect objects from outside the solar system. And we found 4 of them, 2 of which are meteors that we will talk about in a minute, that I discovered with my student, Amir Siraj, that came from outside the solar system. They were roughly half a meter in size. And the third was Oumuamua, that my book is dedicated to. And all 3, from 2014 to 2017, all 3 were outliers. They didn't resemble the familiar rocks, space rocks that we've seen before from the solar system. The meteors, because of their material strength, they were the toughest that were ever spotted among all meteors out of 270 that the US government detected. And Oumuamua was unusual because of its shape. It was most likely pancake-like, and then it was pushed away from the sun without showing any cometary evaporation, no rocket effect. And so it was anomalous. And what I'm saying is, if the first 3 objects are unusual, then we are missing something about what comes from outside the solar system. The fourth one was just like a comet. It's called Borisov, after the amateur astronomer who discovered it. So altogether, this is a new frontier, and we haven't tried checking our mailbox. And the fact that we found these unusual packages tells us maybe there is something out there that we haven't figured out. And so we are planning an expedition to scoop the ocean floor where the first meteor exploded, and it disintegrated in the lower atmosphere of the Earth, and it was tougher than iron. So we want to find out whether it was natural in origin or maybe a spacecraft, maybe artificial. And we're planning an expedition. I was funded at $1.5 million for that. And we will do it before summer 2023, within 6 months. You asked me about funding. Basically, my book brought a lot of interesting people to the porch of my home during the pandemic. They just showed up. A lot of very wealthy individuals that gave me a few $1 million that allowed me to establish the Galileo Project. That we have 100 people involved, and we are starting to get data from instruments that we put together scientifically. And in the coming months, we'll analyze this data. We'll build copies of the first system that seems to work. We're basically taking a video of the sky in the infrared, optical, radio, and audio. And that was never done before with a suite of instruments that we have full control over, that we fully understand.
And will the information, is that going to be publicly available?
Yeah, so there will be an early period where we will make sure that the data is not contaminated with some malfunction of instruments or things we don't fully understand. And then, of course, we will release it, make it open, and also report about it in scientific papers that will be submitted to peer-reviewed journals.
That's great. That's great. Now, so on this excursion, how do you propose that you're going to, is it through instruments that you're going to be able to detect the fragments, if that's what they are, on the ocean floor? How do you plan to do that?
Yeah, we're starting to build the machinery. It will have a sled with magnets on it, so that if there is any ferromagnetic material like iron or other metals that are attracted to the magnets, we will separate it from the muck that is on the ocean floor, the ooze. And in addition, if it's not magnetic, the fragments from the meteor, we actually wrote a scientific paper just a week ago where we calculated the distribution of fragment sizes that we expect, if it's made of iron or if it's made of steel, for example, if it's artificial in origin. And we should be able to find the pieces, most of them of order a millimeter or less, but some of them could be, especially if it's very tough material like steel, some of them could be centimeters in size. And I already promised the Paula Antonelli, the curator of the Museum of Modern Art in New York City, that if we find any gadget, I'll bring it for display. Because for us it would represent modernity, even though the senders might think of it as ancient history.
Boy, wouldn't that be something? Everyone would want to come see that, that's for sure.
Well, let's hope we find something. It's a very challenging mission. The ocean floor is a mile deep, and we plan to spend a couple of weeks there. But the Galileo Project as a whole, I mean, this is just one branch of it, looking for fragments of interstellar meteors. The second is looking at unidentified aerial phenomena that the government reported about, and we are planning to get the data. And then the third one would be to come close or rendezvous, or if you want, date the next Oumuamua, the next object that looks unusual and doesn't collide with the Earth like meteors, doesn't come close, but we might meet it along its path and take a high-resolution image of it. And for that, we are designing the mission, the space mission that would be needed. That's a very expensive mission. It would cost about $1 billion. And to find candidates that we want to date, we have a dating app, which is the Vera Rubin Observatory in Chile, that will start operations in about a year, and will provide us with candidates, and we will choose. I mean, most of the time we will swipe to the left because it's a very expensive date.
It sure sounds like it. Wow. So before we got going here, someone was asking, they're involved in like this Star Watch. I'm sorry, the Meteor Watch tonight, and they wanted to know if scientists are paying attention, or astronomers are paying attention to where Oumuamua is now. Can you calculate how far away this thing is, roughly?
Right. So the problem is that by now it's 10 million times fainter than it was close to Earth. So it's impossible to detect it with existing telescopes. And moreover, the trajectory was not known to a high enough precision for us to chase it or to even look for it at this time. If you wanted to send a spacecraft that will try to find it, it would have to be equipped with a huge telescope just to first spot where it is, because we don't know the trajectory well enough to figure out where it is right now. So it's completely impractical. But instead of, it's just like going on a date and liking a person, but then not having the phone number of that person, so you can't really get in touch. But what the healthy approach, my advice is, if you have such an experience, you better date more people with the hope that one of them will resemble that very fortunate date you had. And so that's what we are planning to do, look for more objects like it.
Yeah. But what you were able to calculate a speed at one time, weren't you?
Oh, of course. No, when it came close to Earth, we know the speed and the direction it was moving. And not only that, we could tell that it's accelerating in a way that is not fully consistent with the sun's gravity. So there was a force acting on it, pushing it away from the sun. And it was not clear what this force is because there was no rocket effect from cometary evaporation. And so I suggested it's the reflection of sunlight, just like the solar sails that we were talking about before with the laser.
Yeah.
Except here it's the sunlight. And actually 3 years later, in September 2020, there was another object that was discovered, which exhibited the same qualities as Oumuamua. It didn't have a cometary tail, and it was pushed by reflecting sunlight. But a few weeks after it was discovered, it was given the name 2020 SO. But it was discovered by the same telescope in Hawaii, PANSAR. And the astronomers realized, oh, it's actually based, if you just extrapolate the trajectory back in time, it came from Earth in 1966. It's a rocket booster that was called Lunar Surveyor that was sent by NASA. And later on, they verified that indeed it's made of stainless steel. So obviously no cometary tail. And moreover, the walls were thin enough for it to be pushed by reflecting sunlight. So here is an example for an artificial object that is pushed by sunlight, not on purpose. It was not designed to be a sail, but it was thin enough. It had a large enough area for its mass. And so we know that it's artificial because we produced it. The question is, who produced Oumuamua?
Right. But we have space junk all over the place, don't we? It's going
Oh
all
yeah, closer to Earth, of course.
Yeah.
So what happens every now and then is that one of these objects, as a result of friction with the upper atmosphere, falls in and burns up, and that we also see. And so there is a lot of junk. But this one, the rocket booster, was launched well beyond the atmosphere of Earth, and at first it was not recognized as such, as our own creation. So, but it just demonstrates that being pushed by sunlight occurs also for our own products, and therefore, it could be that Oumuamua was not a light sail, just like 2020 SO was not a light sail, and maybe Oumuamua is just a surface layer of something else, or who knows what its purpose was.
Yes, and we talked about, when you were on the show before, we talked about this, that it was the artist's conception of the piece was like a cigar-shaped rock, but that's not what was really, it was not thought to be.
Well, yeah, because when astronomers analyze the data, and by the way, this is all scientific data with very high precision. So when they try to model the shape of it, the best fit was obtained at a 90% confidence to that of a pancake, a flat object, and not a cigar shape. Now, even a flat object, if you imagine a piece of paper, when projected on the sky, it may look like a cigar because you see it sideways.
Right.
And that's the reason, that initially people argued is a cigar because projected on the sky, it may look like that.
Right. Here's a question going back to the 2014 meteor off of Papua New Guinea. So Bobby wanted to know, how was the hardness of the meteor determined?
Okay, that's an excellent question. So what happened is I was invited for an interview on a different meteor, and I wanted to learn a little more about meteors. So I went online, and I realized there is a catalog of meteors that the US government compiled as they are monitoring the atmosphere for ballistic missiles, for national security purposes. And then I found this catalog. So I asked my student to check whether the fastest moving meteors could have originated from outside the solar system. If they move fast enough, they're not bound to the sun's gravity. And we found that the fastest one is actually a head-on collision with the Earth. So it was fast relative to the Earth just by chance because it was moving opposite to the Earth's direction. But the second fastest is the one from January 8th, 2014. And that came from the side, and it was actually moving really fast relative to the sun. And it was detected by government sensors when it exploded about 19 kilometers above the ocean surface. And so we wrote a paper about it saying this is actually the first interstellar object ever discovered because it dates back to 2014, almost 4 years before Oumuamua was discovered. But the paper was rejected by the reviewers because they argued, we don't believe the US government, we don't have the uncertainties, and perhaps they're large. And of course, the US government didn't disclose the uncertainties in the measurement because they don't want adversaries to be aware of the quality of the data. And but they need to know if a ballistic missile will hit Boston or Washington. They need to know that. So I was pretty confident, but then it took me 3 years to reach out to people beyond the national security fence. And eventually there was a letter written by the US Space Command under the Department of Defense to NASA, in which it was confirmed that a 99.999% confidence that indeed this meteor came from outside the solar system, that the uncertainties were really small. At that point, our paper, we resubmitted it, and it was accepted for publication in the Astrophysical Journal. And then we looked back at the catalog, we found another meteor, roughly a meter in size, this one not far from Portugal. And we plan to go on an expedition to find this one next, after the first one. Both of them are the toughest in the catalog. And how do we know that? Okay, so here I get to the answer. We know that because the government also released the light curve of the explosion, the amount of light generated, and the flares. And from the location in the atmosphere where the explosion took place, we could tell the stress that the air exerted on these objects. So as they move through the air, there is a certain what is called ram pressure, a certain stress that the material feels. And they survived all the way down to the lower atmosphere of the Earth at very high speed. And that means, since the atmosphere is very dense down in it, we could calculate what is the necessary material strength to withstand that kind of a stress or pressure that the air exerts. And we found that it's larger than the material strength of iron. Okay, and these objects were tougher than all 270 other space rocks in the same catalog of the government. They are the toughest ever. And the chance of drawing them out of the distribution of material strength for solar system rocks is less than 1 in 10,000. So that means that if they originate from a natural origin, their parent system has to be different than the solar system. And, it could be that, for example, an exploding star ejects bullets or small rocks that are very tough. It's possible. We don't know. So the point is, whatever we find down at the bottom of the ocean would teach us something important, because apparently these objects are tougher than solar system rocks. And let's see what we find. It's possible also that they were made of artificial alloys that nature doesn't put together, and that would be even more exciting if we find it.
But someone had a question here, David Jones. He said, what if it's made of a non-magnetic material?
Right.
Like if it's artificial,
yeah,
it could
that's
possibly
that's an excellent question. And so we have a plan B in case it's not attracted to the magnet, all the fragments that we are looking for. In that case, we have a mesh net behind it that we will collect fragments with if they're big enough. So we will filter out the abundant muck that is on the ocean floor and just collect anything bigger than a certain size with a mesh net. So that's our plan to use in addition to the magnets.
I see. And are we talking like a major square mile section that you're going to be searching? I mean, how do
Yeah.
you know where to search?
Well, we know the coordinates of where the meteor exploded, and then we calculate. So, given a fragment size distribution, the small fragments they have a large surface area for their mass, and so they suffer a lot of friction with the air, and they basically rain down straight from the explosion location point. Okay, so they rain down as hot rain because the amount of energy released was a few percent of the Hiroshima atomic bomb. Okay, so what you end up is melting any solid material, irrespective of the composition, and you end up with droplets. So that's like very hot rain coming down, and if you had an umbrella, it wouldn't protect you because it's hot. And then as it rains on the ocean, steam comes up, and then these fragments settle down. So the small fragments would appear just down from the explosion point, and then the bigger fragments continue along the path of the meteor because they have less friction with the air. And then the biggest chunks, of course, follow the path of the original path of the meteor. And so we plan to basically find this strip along which the fragments are distributed, with small fragments first and then larger fragments along the path. And we have the localization to within right now 10 kilometers. So it's a relatively big area that, several miles that we will have to survey. And it's just like mowing the lawn. We will go back and forth, and we don't need to go deep. There is not much activity on the ocean floor. So we should see what we find. It's an adventure and definitely worth doing, and we're fully funded for it.
That's wonderful. About how far off of the Earth's surface was this particular explosion?
Oh, you mean from land?
Yeah, no, how far up in the air?
Oh,
Say,
in the air. It was 18.7 kilometers up above the ocean surface. Yes.
I see.
Um,
Wow.
So it's relatively low, given that this is in the lower atmosphere of the Earth, where the density is not very far from what we find at sea level. It's just a few times lower. So if it were made of stone, for example, it would have exploded much higher up, because it was moving at 45 kilometers per second, a very high speed.
Wow.
The escape speed from the Earth is 11 kilometers per second. That's what you need. Any rocket that you launch beyond the gravitational pull of Earth, that's the kind of speed it needs to reach, at least 11 kilometers per second.
Right. This is an interesting question someone put up there. What is your opinion of the work of John Mack of Harvard? And I guess I want to ask you, has there been any parallels as far as what you have been doing to what John Mack did? I don't know if you've looked into that at all.
Well, no, there is no overlap, because he was interested in people. And humans are not scientific instruments for physicists. I'm a physicist. I'm an astrophysicist. You can't write a scientific paper in physics saying this person told me that. Okay, you cannot do that. There is and there is a good reason for this tradition, because people very often have hallucinations. I mean, they are sincere. They tell you that they felt or had some experiences. They are sincere about it, I have no doubt, but humans can easily be fooled. And we know that when people take recreational drugs, or people have an accident, they have all kinds of impressions that have nothing to do with the reality that surrounds them. And therefore, we don't use people as detectors. Okay? Now, we can use it as intriguing evidence that is worth putting instruments. But in physics, you need to rely on data collected by instruments because it's repeatable. You can repeat the experiment, and instruments do not have personalities. They just do, they measure whatever they measure, and we fully understand how they get the data that we collect. And so not only that you have to use instruments, you have to understand to calibrate the instruments. And for example, when we see fuzzy images from the cockpits of fighter jets, that's not a scientific experiment, because we don't know what the camera was doing when this, or the cockpit was doing when these photos were taken. So science is based on using instruments separate from people that provide quantitative results and are fully understood, fully calibrated and controlled in a way that one understands, because otherwise you can't really digest the information that you get.
All right. Well, another question I have about this is, have you been treated any different since you started looking into this by Harvard?
Oh no,
Here?
Harvard was fully supportive. I mean, there was an initial phase where I was asked whether what I do is related to astronomy, and I said, of course, because in astronomy we use telescopes and look at the sky and analyze the data, and that's what the Galileo Project is doing. And that was a question asked when I started to get funding for the Galileo Project, and the funding is being channeled through Harvard. So it was just an administrative question, but otherwise, no. What I should say is, this is a subject that my hope is to bring to the mainstream, because we are following the scientific method and collecting data the way scientists do in any other respect. Just like in the search for dark matter, we don't know what most of the matter in the universe is, and people have searched and studied various possibilities. And I would argue that the fact that we exist, that we sent probes to interstellar space, and the fact that we know that a substantial fraction of all the sun-like stars have planets like the Earth, implies that it's quite possible and even likely that someone like us predated us and sent probes that by now would have reached us. And we know that most stars formed billions of years before the sun, so there was plenty of time, even for chemical rockets, to make the trip from the edge of the galaxy to the solar system. So now, another thing I wanted to mention is I already said that the paper about the interstellar meteor was first rejected because the argument was we don't believe the US government. It was not because we don't believe Avi Loeb. I mean, it was the US government that was put in question. And now, when we submitted another paper on the same subject after the letter came from the Department of Defense, which came to my defense, which, by the way, is interesting in itself, because it's a very conservative organization, the government, right? And the fact that the government comes to the defense of science, at the frontier, is interesting, because at the same time, there is a lot of pushback from what you might call blue sky academia, and which is supposed to be more open-minded than government. And the fact that I get support from the government for this study was remarkable. I mean, this is not the first time it happened. It happened before, when the US government was looking for a set of satellites to monitor nuclear explosions by the Russians. It was the late 1960s, above the atmosphere. So they were looking for gamma ray flashes, and then they saw it's called the Vela satellite system, and they saw flashes of gamma rays coming. And I'm sure that on the first few instances, they thought, well, it's every day or every few days. What are the Russians doing? And there must have been a lot of troubled people in Washington, D.C. worrying about it. But then it was realized that it may come from far away. And so the data was brought to the attention of scientists, astronomers in Los Alamos, who then published it in 1972 as a gamma ray burst. And they said, we don't know what the source is. And it took until 1997 for astronomers to figure out that these flashes of gamma rays originate from the edge of the universe when the core of a star collapses to a black hole, and you end up producing jets, very, very energetic jets. And if the jet is pointed at us, we see it as a gamma ray flash. And so it's basically the signal of the formation of a black hole from the collapse of the core of a massive star. And that was figured out only in 1997. And it shows you that the data from the government helps progress in science in both instances. But what I wanted to say is, when we reported the second interstellar meteor, and that happened just a couple of months ago, that paper, also on an interstellar meteor, was accepted for publication within weeks. So
Wow.
I can see a shift for the better. We didn't have as much friction.
That's right. I've seen that too. Here's an interesting question, and I hope you may understand it better than I do. Could you please explain nanotechnological and synthetic biology-based multiplexed and scalable chipsat, nanoprobe, and bioprobe technology? Do you understand any of that?
Yeah, well, there was a paper that was just published in Astrobiology. That's a journal. George Church, a colleague of mine from Harvard Medical School, published it. It was inspired by the starshot concept that I mentioned before, where the plan is to send a tiny nanoprobe to the nearest star system. And so what the Church was advocating is perhaps sending out DNA and sort of seeding the Milky Way galaxy with things that we want to plant on other planets far away. That's a long-term project, sending it beyond the solar system elsewhere. There are people that would argue, yeah, we shouldn't be so proud of our seeds, so that to plant them elsewhere. Maybe maybe there is a better thing to do rather than contaminate the universe. But on the other hand, it's a natural tendency. If humanity wants to make copies of things that it finds attractive or worthwhile, then it's good to send these copies elsewhere so that they will not disappear from a single point catastrophe. If something bad happens on Earth, we don't want all forms of life as we know it to disappear. So one way to preserve them is to send them to space, and with the hope that it's just like dandelion seeds, with the hope that one of them will give birth to another form of life somewhere else.
That whole thing about seeds is fascinating, how we have some that are, preserved. We have all these seeds preserved. But anyway, I can't believe how quickly this hour went. I know you have a commitment, so I really do appreciate your time a lot.
Thank you very much for inviting me. It was a real pleasure, and stay tuned for what we find. We should see.
That's right.
I'll be glad to report back in more than half a year from now.
Yes, I would love to find that out. Thank you very much, and nice talking to you again.
Bye-bye.
Bye now. All right, everyone, we'll be back next week, and I don't have a guest to announce yet. There was a change, so I will let you know if you sign up at the website, podcastufo.com, the newsletter there, the weekly newsletter. Just sign up for an email blast for that. Thanks so much, and remember to keep your eyes to the sky.